Hey, and welcome back on my YouTube channel. Today I'm here with Andres. Andres, what are we going to talk about today?
Hey, so today we're going to be talking about several concepts around Amazon Bedrock Agent Core. So we're going to be building a quick little agent and removing the middleman. This is an important topic to me. We're always asking, how are we going to talk to the Agent Core runtime? How am I going to communicate with it through a UI? Am I going to need WebSockets? Am I going to need so many things? And what I want to talk to you about is skipping the middleman, how we can get rid of everything and just communicate directly with our agent in Agent Core.
That sounds really interesting. It's a hot topic these days, and Agent Core has been on my roadmap anyway, so I'm really excited. Today we're going to look at technical details in terms of also code, and we're going to do hopefully some deployments and changes. That means hands-on experiences on how to actually touch Agent Core. And if you have seen what Andres has done before, you know it's always fun to do stuff with Andres. So I hope that you really enjoy this. Andres, I said everybody knows you already when we prepared for this, but still, give yourself a 50 seconds intro into who are you, what do you do, and why the hell do you talk to me?
Yes, so I'm Andres Moreno. I'm a principal software architect at Kalen. I act as an architect on many projects, planning work, designing, working with a lot of AI. I know Johannes from the community. I'm a community builder in the serverless area, but a lot of focus right now on AI. I also manage the Believe in Serverless community. It's open for anyone. Go to believeinserverless.com, join us. And yeah, I'm pretty
Uh,
active in the community, speaking, sharing. I love to share what I learn.
and you're a very, how do I say, energetic and fun person as well. You have been on a lot of live streams as well. That means doing a recording with Johannes is boring for you, right? So if you
Oh
listen
no.
to this session and you feel bored, go to the live streams that Andres does. And they are sometimes more exciting and more funny than all of the recordings. The topic as well, how did you get to it? Like, were you involved in the early days of Agent Core, which is, I think, now 12 months ago or something like that? Or did you kind of start at reInvent 2025?
So I've been playing with Agent Core since the early previews. It went GA what like November, probably a little bit
Yeah.
before reInvent. So I've been playing with that. Obviously, from our standpoint as a consulting company, a lot of our projects that come in are AI related, and we're leveraging a lot of Bedrock Agent Core runtime and all the modules around it. That's a whole topic of its own. But just to run these agents, these chatbots, all these types of agentic workflows. And it's been a really nice experience building with it and using it. Very simple, to
And
be
what
honest.
problem did it solve for you? Like, you're coming from the serverless community. Why didn't you run your agents on Lambda? Isn't that the kind of the same thing?
Yes, and it's a fair comparison. And if you've seen the live streams I've done with Alan Helton, a lot of the agents we ran were on Lambda because hey, we're serverless. But the cool thing is Agent Core Runtime is serverless as well. The biggest difference I see is cost. So when you send a request to an LLM and it's reasoning and it's thinking, it's doing all its thing, Agent Core Runtime doesn't charge you for that compute. It's not charging you for that time that it's running. While in Lambda, if it ran 5 seconds and it thought for 3, you pay for the 5 seconds. Agent Core Runtime, you just pay for the 2.
Okay, so that means that you actually think that you're going to be saving on costs if you use Agent Core versus using Lambda to run your agents. And actually, as you already mentioned, integrating with the other Agent Core components, I think, is also a key point, right?
One point there, right? There's like Agent Core, and we'll talk a little bit about Agent Core memory, and there's other modules that you can just tie in regardless of where your agent's running. That's the cool thing about all these modules around Agent Core. You don't require Agent Core runtime. So if you already have an agent running in Lambda or in some other place in another cloud provider, you can still hook up to these modules as individual services if you think about it. But it does enable, obviously, a tighter connectivity and better experience if you're using the ecosystem.
Cool. And today, are we going to code an agent that does the editing of my YouTube videos for me? Because that's what I'm kind of, that's what I don't like about doing YouTube. Or what are we going to do?
It's a simple agent, so nothing too drastic. We're going to create an agent that writes Python and executes
no!
it.
Can we change that to TypeScript? You know, I don't like Python, Andres, but
We can do it.
let's go. Let's start looking and dive into it.
Yeah, so I don't like slides, so it's not slides, it's charts, it's diagrams.
Slides are boring.
So this is going to take you in the journey of what the steps we're going to follow to build this agent in Agent Core.
It looks very simple. Like, let me try to explain what I see, and then maybe you can correct me if I'm wrong. Like, Bedrock Agent Core sits in the front end of running the agent itself. In the back end, it connects to Bedrock, where I can then consume Claude or Nova or any other model that I would like to consume through Bedrocks. And
That's
can
exactly it.
power Agent Core by runtime in memory, I would say.
Yeah, so Agent Core is a set of like 9 modules, right? So you have runtime, memory, policy, eval, browser tool, code interpret. There's so many things. In this situation, I'm just going to try and use runtime, which is where the agent runs. This is where the code lives. This is our compute. And then memory, it's providing memory if you're building a conversation app or something that requires the previous context. We can use memory and simplify that management so that conversation stays there. It's short-term memory. It also offers long-term memory. So you can use both. In this case, just for a short conversation, short-term memory, and you don't have to re-provide all the context, and it just takes care of it.
Okay.
But yeah, your assessment was accurate.
And do I need to tie it to Bedrock, or can I go with I don't know, OpenAI or anything else as a backend, or am I forced to connect it to Bedrock?
No, I mean, I just like to use Bedrock and all the models, keep it in the AWS ecosystem, but from Agent Core with any LLM, as long as you can not even LLMs, right? If you have your own model and you can run against your own model, you can do it from Agent Core runtime, right? So you don't necessarily need or require to use Bedrock to communicate with the models.
Okay.
Cool. So step number two here is, okay, how do we communicate with these agents? And this is like a typical workflow. So you have a web application and it's a chat application. You go through API gateway. You then trigger a Lambda function to then trigger your Bedrock Agent Core runtime, and then run the analysis and then send it back.
And that's kind of the way that I've been building GenAI applications as well, right? So you know that I'm building like that social media scheduler, but I recently also launched a vocabulary training app for my kids, and that also uses a similar pattern at the end, right? I'm not using Agent Core, but directly talking to Bedrock, but at the end it's the same.
Yeah, and that then you need to stream it if you want, like that. How you see ChatGPT or Claude responding, you would stream it back. So then you stream from, in this case, from Agent Core to Lambda, from Lambda to API Gateway, from API Gateway to your web application. So that's kind of your typical, like you said, you're building that way. So I'm not wrong in that it's a regular use case or scenario that people build for. Then there's a separate situation here. You want to provide that WebSocket, kind of you want to stream it back, right? So this is one that I actually built before I learned what I'm doing in page 4 of here. But this is, okay, Amazon API Gateway, then you can trigger it more asynchronously via step function. Again, I'm a community builder in the serverless area, so you can see all the serverlessness comes to show here. In a similar way, you have your Lambda function, you have Bedrock Agent Core, you get your response, and then you want to share the responses back. So you can use something like AppSync events for WebSocket connection back to your UI, right? This is a real, not a real diagram, but a real implementation that I actually did in a project before I learned how you can skip most of this and go directly to Agent Core. So here you can see very simplified, and I have my web applications communicating directly with Agent Core. Agent Core has a WebSocket connection piece that is, I'll show you how that looks. But it communicates with Bedrock and the LLMs, and then is streaming the response back to the UI securely without any extra components in the middle.
Cool. So that simplifies a little bit the way that my connection gets from the browser or from the web app back to the to Bedrock itself. Like there's 2 hops less than before, right? That should speed it up as well, right? And from an integration perspective, I guess it's also going to be a little bit simpler, right?
Yeah, and it's that piece where you're streaming from Agent Core back to Lambda, back to API Gateway, back to UI, right? Or sending it through AppSync events or any other WebSocket connector. So it's just reducing a lot of the friction that you get. Or not friction, but all the components, right? And I'm a minimalist, or I like simplicity, so this reduces a lot of that.
It does. Cool.
So
let's look at it. Let's look at the code behind it.
Yeah, so I have it kind of in steps. So I want to first get people to like, hey, it's simple to build an agent. And here I have, this is the base of building. And let me zoom in a little bit here. Make this smaller. So here is an agent core. This is how you define it. So you have your runtime. I'm using Strands Agents as my agentic framework, but you can use any, right? This one's provided by AWS, integrates very nicely with all the services I'm using, so very cool. All you have to do to enable the entry point for your Bedrock agent or your agent core runtime is add this. What this actually does is it adds 2 endpoints for you. One is the invocations endpoint, which is the one that you actually call via HTTP to be able to trigger the runtime. And then it has a ping endpoint just to make sure it's alive and well. Here, we're simply getting our requests, right? Hey, what's your name? Whatever request we're sending, we're instantiating the agent via Strands and sending our request to the agent and getting a result. So if I were to, 1 second, let me copy something else, run this agent. So I'm going to be doing just directly. So this is an easy way to test your agents. I'm going to do Python, and then this is an agents, demo agent, agent py. So this is where my agent's running. So here I'm basically spinning up my agent and it's running, right? So in a separate terminal, I can then go and call
and talk to the local agent at the end, right?
Yeah. To the local agent. So here you can use Postman or whatever. Here's just curl, calling that invocations endpoint that is being enabled by this app.entry point, and then sending it a request. What are the stages of the water? Right? Simple enough. Where I mess up? I might have an extra comma here. There we go.
Strange.
Quick troubleshooting.
That's what we need. It makes it live, you know?
Yeah. So here we can see it went through this, instantiated, sent the request, and responded. So here's the request. Here's my response. Water exists in 3 main stages. Blah, 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 blah. Cool. Right? So here you can start iterating. But, I'm not going to stop there. So once you have
is this now your agent running? Or is this... Okay, cool.
So here I am authenticated against AWS because I am using... Natively, it's communicating with an LLM, right? So that LLM lives in AWS via Bedrock. By default, it runs Sonnet 4.6, I guess, at this point. So that's defaulted, and we'll get to how you can change the model. Here, I don't want it to just be any type of agent, right? So
of course.
I have so how do you make it your agent, right? So personalized. I don't want a proxy just to Claude. So what you do here, and I'm copying from a separate screen over here because I don't want to type all this by myself. So what we do is add a system prompt, and what I tell people what the system prompt is giving your agent a personality. What can you do? Who are you? What can you do? What what should you not do? How do you should you respond? What format do you want to respond in? So here, let me do Alt
So
Z. See,
the system prompt is a little bit more restrictive than the normal prompt. It gives the model that you're using in the background some additional guidance that needs to be followed by the model itself, right? So it's stronger than the user prompt at the end, right? For those that
yeah,
haven't
and
used those, yeah.
the user prompt is typically, if you're talking about a chatbot, it's a user, literally, your end user prompt. And then you have your prompt where you're kind of giving it guardrails, like I said, a personality. Like, hey, don't use
Yeah.
excessive emojis for your responses because it looks a little bit
As an
unprofessional.
example, or maybe
Yeah.
like Andres, today you're coming on a show to record a YouTube video focused on this YouTube channel. That would be the personality that you have today, and you're going to talk about AWS, right?
Yeah.
That I think makes sense to explain. Yeah, but let's do. I don't like Python. No, let's do TypeScript if you don't mind. Let's just copy paste and replace. Yeah, just to challenge you a bit, and then expecting that it's always going to work, of course.
There we go. Yeah, changing what I
Yay!
tested. TypeScript, I'm not going to use
Yeah,
a
it doesn't matter. The
version.
version doesn't matter in this case.
TypeScript. Show the most TypeScripty, I guess.
There is down there an example of a npm install exact.
I could have used an agent to just my Kiro to just change this.
You could just have used something stupid as search and replace. I heard that still exists, even though we only use AI coding tools.
True, but yeah,
we tend to forget that, right? Yeah, we are.
And I call it the 1+1 scenario where I don't know if you've been in like a math exam or a physics exam and you're just typing in the calculator and at some point you type in 1+1. You're like, should I have done that?
Yeah, that happened to me as well. Okay, so we changed the system prompt. I think we still need to push it to the agent, right? So the agent still
we need to add it here. So this is using Strands, so they have a parameter to provide the system prompt here. So we have it, and it's the TypeScript now, the one that you just changed on me. So now we need to obviously rerun our agent. So I'm going to Python, just directly run it locally. And I'm going to rerun the same request. We're telling it to not do anything that's not TypeScript related, right? So this should get rejected.
Let's see.
I'm a TypeScript coding assistant and can only help with TypeScript, right? So there's more advanced way to protect your agents from these types of things, but your start is with the system prompt. So your base level guardrails can start there.
Yeah, I think every coding IDE, every IDE needs that system prompt. Never generate Python code, and the world would be a better place, Andres.
It's, I'm a JavaScript guy, and I've been slowly shifting to Python as I work on more agentic systems.
I'm so sorry for you.
But let's say now, let's do something that actually works. Create a function. Hello. Let's start with the hello world function, and we can make it more complicated as we advance. Function. And it's tied to TypeScript, so I don't even need to say in TypeScript. So here it is. Here's the 3 backticks for TypeScript. I do have a UI prepared in a little bit, so we'll show this in a better way. So,
but this already looks like it directly worked, right? Now the agent is currently running on your local, and it's not running on Agent Core yet, right?
It's not running on Agent Core. Everything's running locally, still communicating through Bedrock to an LLM and AWS, which is why I do need to be authenticated, because then this would fail. So we know it works with the LLM in the cloud and it runs locally. So what's the logical next step? Let's deploy it. So this is where we might not align. Maybe we do. I don't know if you're a SAM or a CDK person, but I have...
you know the answer, I think.
Yeah. So I use SAM. And that's where I have my knowledge. This is all easily transferable to CDK.
And I'm always eager to learn, Andres.
Yes.
And
So
CDK is just a prompt away, right? Anyway, so
yeah. So I have a few things here, right? And how do you deploy your agent core runtime? And there's several deployment patterns. One is you can build your container image, push it to ECR, and do a bunch of stuff. But like I've said, I like the simple paths. I like the easy way. So I'm using the one that's called direct deploy, where you basically bundle your runtime as you would like a Lambda function, right? So you create a zip, that's a pre-built zip, and upload it to S3, and then the agent core runtime reads from the S3. And I do have the scripts somewhere in the scripts folder, so let me open up scripts. Here's the package. This is AI generated. You can see all the comments there. But this is using the example from the docs in Agent Core. So this shouldn't be surprising to anybody. It's doing a bunch of input validations, but then it's running this UV pip install. It has to run on ARM64 and then my Python version, and then where it's going to drop all the files.
And that's now how the agent is going to be run, right? It's not the code that is being generated. It's really how the agent.py that you just showcased, that we just changed, is going to be executed on agent core runtime.
Exactly. It's packaging basically that agent py file, the requirements file, and sending it to S3. That's zipping it up, right? So here it's creating the zip.
Okay.
And then it uploads that to S3, right? So we won't go into the details of the script because that's documented in AWS things. And then I have this full deploy one, which runs SAM deploy. So it packages it up and then it provides the inputs to SAM.
This is a very highly sophisticated CI/CD pipeline, you know?
Yeah, I usually do it in GitHub. I usually have my GitHub workflows do all this for me.
No, but for speed, it's better to run it locally, so it makes total sense.
Yeah. So the deploy is running that. So if we look at our template here, we have our agent core runtime, and we're providing a bucket and a prefix. AI coding agents will try to change this to key because it's actually providing the full path to the zip.
Okay.
But it's thinking of the zip path as a prefix
for
the items that are within the zip. So it's kind of weird. It's a prefix, not a key. But here is where we're providing that full path and the bucket name. What's our entry point? It's agent.py. And then we have a role. All of this is documented, right? So what it needs to be able to get the zip file, do logs, do a bunch of stuff, invoke the agent core runtime. So this is just the role, the execution role for the runtime. So if your runtime is querying DynamoDB, it'll need a permission to query DynamoDB. And then I have the agent core short-term memory. So I'll just show it here so we don't have to come back to the infrastructure as code. But I have a short-term memory with an expiration of 30 days, right? So anything that's 30 days or older will not exist.
Okay, good.
So if I just go and run...
But we didn't connect the agent to the memory yet, right?
No. Not yet. Yeah, I'll just have that resource deployed.
Yeah, of course.
So deploy.sh, and I have it by steps. So it doesn't deploy everything. Step, let's do 3. So here you can see step 1, it's packaging everything. Goes pretty quickly. Then it's uploading to S3. Then it's running SAM build and SAM deploy. So this will get us everything there. So now what I can do, let me open this in my file explorer. Where is it going to show? And I'll open this. Oh, actually, it's easier than that. So over here, we don't need this running locally anymore. And give me a second because I lost you.
You lost me. I'm still here. You don't need me. Keep going.
There we are. So here what I'm going to do, I have this little test server. So if I just npm run, and I need to remember the test UI. test UI.
Oh, the highly sophisticated UI that you created.
Yes. So now if I go to localhost, we have my UI.
Yay! But the runtime will change now, right? So
Yeah, so this is now pointing. So this is actually going through the direct invoke. It's using my local credentials.
Okay, got it.
So I am this path that I'm going to show you will be the equivalent of the API gateway Lambda function trigger. If I ask it create a hello world function, we'll now see it here. You can see it's waiting, so it's very request response. And here it is, right?
Yeah,
so here's our Python code with the example usage and the explanation. So the next step in our journey is adding that. Let me see. I do have adding the WebSocket support. And this is where it gets a little more interesting, at least for me. And I'm going to copy it from over here. Let me copy it to our agent. And we'll see all the new things that came to be. So here we have our system prompt. We'll go through the
and
Bedrock
we can stick to
ID.
Python. You don't need to change it back to TypeScript. We saw that it works.
Oh yeah, true. I can copy the. Oh no, we changed it.
Doesn't
so here we'll see one new thing. We're providing the model, and we're saying, hey, it's a Bedrock model, and it's Bedrock model ID. So I'm telling it to use Nova Lite. I have AWS credits. I don't want to keep getting charged by Anthropic, so I'll use Nova. So here we'll see we still have our entry point, the same one. We've just abstracted the create agent because we're using it on two different entry points, but this is the one we used, which is the straight up invoke kind of request response kind of situation. And then Agent Core provides this app.websocket. This opens up a port so you can create that WebSocket connection, basically.
Okay.
So this looks a little bit different in that it needs to run.
So is this provided by Agent Core? No, this is provided by Strands, right?
This is Agent Core. So this is not part of Strands. What we're doing with Strands is limited to this.
Okay, got it.
So here you can see we're receiving WebSocket. So we get the data, we get the request from the data. If there's an error, we send an error. But if not, we create the agent. And then we call, instead of just calling the agent with the request, we do this stream async with the request. And then it's just doing a bunch of stuff.
We've sent the JSON back. Okay, yeah.
Yeah, so here's where it's sending the event back. As it's receiving it from the LLM, it's sending it back to the UI. So if I know now, go back, we'll need to restart this. But if I now go back and deploy step 5, which is the one that actually has all our Agent Core stuff, or our WebSocket stuff. I should have started the deployment before I explained the code, but
no, man,
shouldn't take that
no
long.
No worries. Okay, so now we're deploying the WebSocket part. Once we deploy the WebSocket part, the UI will need to connect to the WebSocket. Then I can execute something, and then the way that the data is being returned is going to change, right?
Yes. And if you look at my little UI, I actually can keep it running right now. npm run test UI. I'm just not going to connect yet. If you look, it's this other window. So if you look at the UI, I already have a connection.
Yep.
Here. The WebSocket connection uses presigned URLs, right? So I don't know if you've heard of the S3 presigned URLs. Similar concept. You create a pre-signed request with a signature, authenticated signature with an expiration to be able to create that connection. So in this case, it's creating that pre-signed URL using my current AWS connection, right? So I'm that terminal where I'm running this UI server is authenticated using my credentials and I have access to Agent Core Runtime, so it creates that URL for me, and we can share this code, all the code that I'm showing. But once this is finished deploying, it's done. I can go back here, say connect.
Okay.
Maybe.
Didn't you need to change the ARN in the background or the? Because you
It should have
redeployed.
been. Yeah, but the ARN, the Agent Core ARN is the same one. Let's
Really?
see. I guess we'll.
Because the generated ID at the end might be different.
Yeah, let's see if it did it differently. Let me refresh. Safe. Okay, so it is actually connected. So here, my fancy UI, you can see now we have two boxes, so you can see the difference of how it behaves. So if I ask it, create a hello world function, sorry, it's now going to come back in Python.
That's okay. I can live
But
with that.
you can see how it had to wait. I don't know if you saw the difference there. So let's make a little bit more sophisticated one. Create a function that reads a PDF and processes it to get all the filler words. I don't know. Just making things up. To get, it's too protective. Hey,
Ah.
it at least was consistent.
Yeah, it was, but in the time was still different, right? But
Yeah, you can see it's faster.
on
Yeah,
the
it doesn't like reading PDFs.
then let's do
Create
something
a
else.
It's a little bit different. So here it is. This one you can see it's writing, and while the other one's still waiting, and then the other one comes back. So a little bit different experience. Again, if it's like a chatbot or something, you really want to provide that. Hey, it's feeding in. It just keeps you all excited when you see information flowing in. So you really open that experience up without adding all the extra components. Because one of my initial ideas before I learned that there was native WebSocket support, I was like, okay, I'll have an AI agent, and then I'll have a tool within there that gets called with the bits of information to send it off via WebSocket connection. It's like, oh yeah, it's a little bit too much. So it was nice when I saw that, and it's a relatively new feature, this WebSocket support.
That's pretty cool. Yeah, so you get a direct connection. Like now, did you register through the WebSocket directly with Agent Core? No. Can you show that code again? I kind of missed that in the UI. Or we
Yeah,
didn't
so
talk
the
about it,
UI,
right?
I haven't shown the UI, so let me just
Yeah,
dive
I guess it's
here.
really highly sophisticated, right? So
Yeah, of course. So here, boom, boom, boom.
there's the WebSocket URL that you get. Okay, got it.
Yeah, so here's the WebSocket URL. This is the
Yeah.
pre-signed URL that creates the connection. So it's not terribly complex. You can reconnect. Then here's where you're sending the message, and nothing too terribly complicated here.
Yep,
I
cool.
know it's
Makes
a lot
sense.
of code.
Makes sense. Yeah.
So I do have one more step. Well, it's the memory,
It's the memory
but
that we need to add, yeah.
yeah. So for the memory, it's step 6.
So
So
let me try to understand that. What that means now, without the memory, if you restart the UI, it's going to come up empty, right? So like, if you turn off the UI and connect it again, right? You will not see any history, or what's the
it's more
difference?
like this, right? So if you were to ask it here, what are the functions we have talked about? I think it's going to fail because of the restrictions I've given it. Yeah, I'm only a Python. Yeah, so it's too
Yeah. Okay.
restrictive.
Okay. Got it.
So we'll remove for step 6.
So
We'll
as
remove.
yeah. So as
I
part
actually
of
removed it here.
yeah, exactly. So as part of integrating memory, you will now need to change the system prompt because it was too restrictive before, right? And you
Yeah,
also need to do the connection of the agent to agent core memory, right?
Yes. So
Okay.
if we look here, the system prompt, basically for this example, I've removed like the standards and the example decline. So you can see here, well, I do have the standards, but I'm telling it you can do whatever you want. So it's not fully restricted like we've been doing it. And then there's, as part of Strands Agents, there's what is called a session manager. So this is the simple way for managing these memories. If we didn't use Session Manager, we would need to manually go and send that message to memory and then retrieve memories as we're starting up a session or continuing a session. So Session Manager handles that for us via the agent framework. So all that we're doing is giving it a session ID. So a session ID in Agent Core is what creates basically an isolated micro VM. Think of it as an isolated conversation. That's your session. If you stop that and start a new session, completely new conversation. So it's kind of the level of abstraction you can get from conversations. And then we're creating the session manager with that config. So we're giving it the memory ID. This is the one you saw already in the SAM template. And then we use this and give it to our agent via sessions manager, right? So pretty straightforward. Let me run the deployment as well. So now we're doing step 6. So now we'll have memory with the less restrictive prompt.
Yeah, of course. So in order to allow me to ask the agent some questions around the history, he needs to know that he's able to allowed to answer me as well, right?
Yeah. Yep. Yeah, and it's things you learn from. It's the prompt engineering aspect of this and evaluating your prompts. It's, hey, what you can add guardrails, but is it going to prevent you from something? And as you can see for this demo, my heavy restrictions prevented me from showing you that.
And that's okay.
That
That's
quick
better
example.
better than being too prohibitive at the end, right? So
Yeah. So once this is done, we'll rerun our. This is done. So now we'll rerun our test UI and we'll ask it a couple questions. What are you feeling? Create. Let's do.
Let's solve simple math problems. A function to solve simple math functions. You know, I'm a math guy. And then what do I need for my current project? I need well, it's your tokens at the end, right? That we're spending right now.
Yeah, it doesn't matter. Go heavy on it. Use it.
So let's do. What do I have? An AI training generation function.
Let's see what it does.
I don't know.
Look at that. There it is. It has training data, synthetic. It's creating synthetic data. It's doing some vector. This one failed.
Okay. Anyway, I think we showed what we wanted to do, right? But you can see now without the system prompts, it's also generating Markdown, right? So like with the changed system prompts, it starts to generate Markdown, which is not only code anymore. So it's now way more than a coding assistant, right? So I think that's some stuff that the demo we could improve a little bit, right?
And now that I reduced the restrictions, it's what have we talked about? We have the math problem and we have the training data generation. Without the memory, it wouldn't know. It would say, we haven't talked about anything.
Yeah,
I can help you with this, and that.
Of course. And that's just because we connected the agent to memory, right? To agent core memory at the end.
Yeah, with the session manager. So that's all we had to do in that scenario. How are we on time? There's one other step. We can drive questions, but there's the tooling aspect.
Let's go to the latest portion that you have. We are at 40, so we can cut things out. We're gonna end up 13. So yes.
Okay. So the last piece I have is, basically what we've created is a chatbot. And then how do I make this a real agent if you don't know the differentiation between a chatbot and an agent? Is basically the agent can do stuff. The chatbot is you give me a request, I give you a response. An agent has basically a goal. It reasons about the goal. It uses tools to get to that goal, and then it comes to the result. The biggest differentiator being the tools in the middle that it can access. So right now we're going to add tool to make it an official agent.
Okay, so that means now I can power up the agent with additional capabilities by giving him access to specific tools. What kind of format do the tools need to follow? Can I just give him any tools, or?
So there's some pre-built tools that Strands gives you to calculate date, or like that calculator function that we created. There's a calculator. There's simple things that are pre-built, but then those are not enough, right?
Okay.
We always want more. We need
more. Of course.
So you can add your own tools, whether that's, hey, I already have an API that does all this. You can expose it as a tool and call it from your agent. The big concept here, maybe we can talk about this in a separate talk, but it's MCP, right? So providing your tools as MCP servers. MCP is the Model Context Protocol that allows agents to, it's the standard for agents to communicate with tools and how they discover them and know what these tools do, to know what to do with them. You can expose them. And here I'll just do a quick mention. Agent Core Gateway gives you that ability. If you have a Lambda function, you can expose it via MCP through Agent Core Gateway. So you can really extend your application, as we've done for many years with serverless architecture. But now it's that service in the middle, Agent Core Gateway, that can allow us to call those Lambda functions from Agent Core Runtime.
Okay.
But here, it's going to be more inline. We're not going to call externally to a remote server, an API, but you can update databases and whatever you need your agent to do. So here, we've added this tool. So we're creating Python functions. I want it to be able to run the Python functions to make sure it works. So here, this is part of Strands Agents. And you just decorate this function with the @tool. And here we're telling it to run a Python process with the code that it got provided.
Okay.
And share the output. That's about it.
Yep.
Right.
Cool.
So here we have this. We've modified our system prompt to say, hey, tool usage, when you write code, use the run Python tool. Execute it to show their actual work. Always run the code you write.
That makes sense. So the tool usage is like a standing term for LLMs, or is it just like you can put whatever you want and the LLM will understand it?
What do you mean with the tool usage in this decorator? So here we're just defining a function. Basically, we haven't tied it to our agent. LLMs understand tools. And that's kind of the language, and how you expose tools is with a description and what can it do, right? So it's a big part for the LLM to know which tools to use. How we tell our agent, hey, you have access to this tool or you can use this tool, is if we go to our agent, and Strands Framework has this tools array where we're telling it, hey, this tool can run, and this is where you can include any tools that you've defined, whether they're defined inline or externally. This is where you would import them basically for your agent to use.
Okay, so this is expanding the capabilities of the agent then to the tools.
Yes.
Good.
So and while
that kind of and so like building your own tool seems to be very simple then, right? So you can. Did you do that already as well, or is it just?
So here's the tool. It's just a function.
It's just a function. Okay, but I can also include external ones. This is what
external ones, or like I said, if let's say you create a tool that you want to use for 5 agents that live in separate repositories all over the world, you can abstract that into a Lambda function and expose it via Agent Core Gateway. And that way you can share the same logic, maintain it separately, and have your agents included in there.
Okay,
So
cool.
this is finishing the deployment. Do you have more questions? I love questions.
I have always questions. I just didn't know what to ask without putting you on the spot, Andres. But
Oh, I love being on the. If I don't know, I don't know, right? I
how
have no
how many
shame.
agents did you deploy in your past career, in your experience?
In my career for like
Like
real
since
clients,
agent,
not for my
yeah,
personal.
yes.
I have like 5 or 6 under my belt
And
for
are they
clients.
running
For
24/7, or are they only run when being invoked?
they only run when they're being invoked, right? So that's the serverless nature of Agent Core Runtime. You only pay for the uptime where you're actually using it.
And how much money did you spend with AWS with these 5 agents that you have in production?
So I don't follow up. These
Okay.
I'm a consultant, so their projects. I do the calculation, but honestly, I don't know if you've done cost analysis with Lambda. It's very similar. You have to go to the millions and millions to get like a true thousands of cost, um, or having an agent run for a long time to know those mixes. So
Of
it's a
course.
similar cost pattern as with Lambda, where it's 500 invocations per week. It's like it's probably gonna be 2 cents, but if so, no true heavy cost that I have hit. I've have like 10 agents, personal agents, and I haven't gotten like a scary check. I get
Okay.
mostly cost for like when I'm using Anthropic. That's where I feel the cost rather than the agent core runtime.
Okay, makes sense. Deployment done. Let's see.
So here it is. Now you can see this. Let me run the code. Great, the function works. It prints hello world as expected. So it ran the tool, grabbed the response, and is telling us, hey, it actually worked.
Cool. This looks simple. Looks simple. Thank you very much. And we have gone very deep. So let's do a short wrap up, Andres. What do you think people learned today? Is the first question. And the second question is, what do you think Johannes learned today?
Cool. So there's 2 main things that I wanted to achieve today. One is like, hey, look how simple it is to create your own chatbot/agent. Go do it. Play around with these. Get familiar with it. Be less afraid. That's people are like, where do I start? I want to create an agent,
Hmm.
and I struggled with this for a while until I actually started doing it. And a year and a half ago, it was a lot harder
Mm-hmm.
than what it is today. And I wanted to showcase that. And it's not just in AWS. Every cloud provider, there's many services that have simplified this
Mm-hmm.
for us. Go and leverage it, try it out, and get excited about it.
Okay.
It's just very cool when you see it working. The second piece is that direct, and this is for you, Johannes, and I know we've talked about this direct connection to Agent Core Runtime, removing like 3 layers of compute or processing. It simplifies your architecture. Like I have a slideshow, like a presentation going through this. It's like I'm gonna show the backend now. This is gonna be the most complicated part. It's like this is where we're running the code. We have to connect to an LLM. We have to manage the memory, all that. And then I change the slide, and it's just Agent Core, right? It's like okay,
Mm. So that means that if you so in all of my AI applications, and I have a few of them right now, I directly invoke Bedrock from Lambda. Would you advise me to move over to use Agent Core there and not use Lambda anymore and directly and with that access Bedrock, or what's your current advice?
I would change. And I know you like learning and being aware of stuff. I would change at least one into Agent Core Runtime and see how you feel. I don't know the level of workloads you're running. I don't know if you're paying for Lambda, and it's like, oh, I'm paying $500 for Lambda. You might see a cost reduction if your agents are running for 10. seconds, and you should only be charged for 2 of those seconds.
Okay.
Right. So I would suggest moving at least one. Get familiar. You might like the experience, and you're like, oh, why am I still doing it with Lambda? So Agent Core Runtime is specifically meant for that shift, and it should be pretty straightforward. It shouldn't be terrible. You saw the code. It's
yeah, I saw the code. It's
bad.
not that terrible. Okay, cool. Thank you very much. I think I
really
learned
appreciate
today.
you having me today. I love sharing things with the world. So,
and I think this is a good session for people to get started with Agent Core. So we'll use it accordingly, right? And then get people to create potentially TypeScript code instead of Python. Obviously, right? Should be pretty simple to. Is your repository public, so we can share that as well with the end users?
So this specific one I created to be able to go step by step. I do have, and we can share this one, which is the one I've been building up. It's called Study Buddy. The system prompt is in Spanish because I've used it for presentations in Mexico.
Okay.
But this Study Buddy, you can see it has both paths. So it has the API gateway path, but it also has the one we just talked about with the WebSocket.
Cool.
So
then let's link that. Yeah, that makes sense.
Yeah.
Andres, how can people ask you more questions and go on your nerves if they want to learn more from you and about the stuff that you're doing?
So I am and more dev on everything. So look for me on LinkedIn and more dev. I've started my Instagram profile with tech related stuff.
Ooh,
so
really?
Trying to get that in an active mode. So you can follow me there. Trying to share like shorts or things, quick insights into what I've learned. And more dev on GitHub, and more dev on X, and more dev on. No, I'm not. Don't do Facebook. I don't like Facebook.
No, I know what I'm gonna do next, at least. Right? I'm gonna do go to Insta and subscribe to and more dev. I didn't know that you started Insta yet. So Andres, thank you very much. It was, as always, with you fun. I really enjoyed. I hope that a lot of other people enjoyed this as well. And that you learned something. And if you did not learn anything, please complain to me. Don't complain to Andres, because we aligned on doing this. But if you still want to complain to Andres, go to him. And if you want him to get beaten up, go to Alan so he can beat Andres up a bit. That might help him, maybe. Have a great rest of your day, and looking forward
Thank you.
to see you soon, my friend. Bye-bye.
For sure. Bye-bye.